Okay, so I want to do this problem on using the integral test. Okay, so the question is determine if the following integral converges or diverges, and compute them if they do in fact converge. So we're going to look at the integral between 0 and infinity of cosine of x dx. Okay, so an integral will diverge if the area under the curve, let's say this one, between these two endpoints, keeps growing without bounds, and it gets larger and larger as you between these bounds. It doesn't hit a fixed area. Or a divergent integral could also oscillate between two different values, two different areas, or a couple of different areas. It doesn't actually approach one exact area. So let's take the integral using the integral test of cosine of x. So the antiderivative of cosine of x is sine x. Okay, and then we'll evaluate it between 0 and infinity. Okay, and we're going to get sine of infinity minus sine of 0. Okay, so sine of 0 is 0. So here I drew the sine curve. Okay, sine of 0 is 0, so we could get rid of this. So we could say it's equal to sine of infinity. Okay, and so what is sine of infinity? So it's saying when the angle is getting larger and larger and larger, what would be the sine? So here's the curve, the sine curve. So the sine curve is going to start 0 over here. Well, actually, it keeps going back this way. But let's say we start, well, we're doing between 0 and infinity. So between those two endpoints, okay, it's going to start here, 0. It's going to go up to 1, down to -1, up to 1, down to... It's, as you're going this direction, it's not going to actually approach an actual real number. It could be, it's going to keep going between every value between 1 and -1 as you go out this way. It's not going to approach a real number. So therefore, we'll say the sine of infinity does not exist. Okay? And since this does not exist, that means this integral does not exist. So since this does not exist, we cannot say that this integral will converge. We're going to say it's going to diverge. Okay, so you're using the integral test. The integral has to exist in order to possibly converge. If it doesn't exist, you're going to have to say it's going to diverge. It's not going to approach an actual value. So let's take a look at the cosine curve, and let's take a look at the area under that curve and see what's happening. Okay, and so forth. Okay, so here at the highest, it's starting at 1. The lowest value is -1. Okay, so just like the sine curve, it's going to oscillate between 1 and -1. So we're trying to compute the area between 0 and infinity. So as we're going out this direction, the area is going to pick up this amount of area over here. Okay, and as you keep evaluating out this way, it's going to pick up this area. Now this area is going to be the same exact area as this, but it's going to be negative area because it's below the curve, below the x-axis. Okay, and then as you continue, it's going to pick up more positive area. And as it continues, the same process will happen again. It's going to pick up the same amount, but negative, the same amount area as this, but negative area. So the area that's picking up is not actually going to hit an actual definite amount. It's going to get larger and then back to 0 at this point. Then it's going to pick more, and then this is going to cancel it out. So it's going to keep oscillating between positive area and 0 area. So that's the reason why this integral is going to diverge. That's the reason. Okay, thank you.